Alright, I think you're all seeing my screen by now. So really, the idea behind location intelligence online is that it's hosted in the cloud, right? It's software as a service. And as Miguel said, it's really geography, which is made much easier. So it's simplicity, its ability to produce analyses based on data, and I'll show different ways we can import that data, is really what gives a product strength. So it's not onerous in terms of deployment. It does have the ability to very easily and quickly get layers into the map, which I'm going to demonstrate, and of course has the ability to talk to different layers, which may be stored in, for example, databases or Oracle Spatial, for example, Microsoft SQL, and so on. So what I'm going to do is log into the application. And really what we'll see is a series of predefined analyses that have already been created. And when we create these analyses, we have the ability to dictate, to set up which part of our organization or which particular user group can have access to one or multiple of these particular analyses. In this particular case, to start off with, what I'm going to do is create a new analysis. So it'll be an empty map. And we see a background map here of South Africa, which is by and large where we're going to start our demonstration. Once we go through some of the applications within the South African context, we will then branch off and indicate and demonstrate some of the demographic information we have available for countries outside of South Africa. We have a list of data availability and the countries which we have data for, and I prepared analyses that speak to applications in Maputo and both Kenya as well. So to start off with, you'll see that on the left-hand side, what we have is imported layers, right? So these are layers that are existing already, which we could use as part of our analysis. So these have been imported, in this case, using Microsoft OneDrive. Of course, we could use Google as well, or they could be coming in, as I said, from a particular database. But one of the key features of Location Intelligence Online, powered by MapIdea, is that we have the ability to drag and drop different layers into the map directly, right? So in this instance, what I'm going to do is select my FTTX network, and I want to drag and drop that into my map. Right, it's going to create a layer for us called FTTX network. We see the ID, the map, the tab, and the DAT file. And I'm going to go ahead and create that. So this is really how we can import layers on the fly very quickly and very easily and get them into the application that we can start doing our various analysis. And there we see our FTTX network. Now, to understand the attributes, what I'm going to do is pull up at the bottom a little tabular view of what we have available. Really what we see is we have status, we have potential, we have network level, and then total length of the various fiber or fiber network. So these are the attributes and variables that exist within the layer. What I'm now going to do is overlay a smaller sample of customers. And by the way, this is all sample data, so it's not true to life, not a network that belongs to a particular client necessarily. It's just to showcase the ability and the flexibility of the product. And so what I'm going to do now is, as I said, I'm going to bring in the customers and overlay them and drag and drop them into this particular workspace. And we'll see a series of red circles appearing as the customers are loaded. Now, as we'd expect, for these layers, we have the ability to control certain functions and features. So let's say, for example, we didn't like the look and feel of these customers because we feel that the red circles may be too large. What we can do very easily is when we click on customers, we have the ability, and this is really for any layer, to step into its settings. And when we go into settings, we can add a little style override. So perhaps what we'd like to do in this instance is just reduce the size of the circle, say, down to about 5. And I'll go away and apply that. All right, so we're seeing now a much neater representation of our customers and the fiber network as well. The question, of course, is so what? And what can we do with this information? Well, there's a lot of stuff we can do. We can understand proximity of customer in relation to our particular network based on status. Is the fiber network ready or is it planned? As we progress in our demonstration, we're going to have a much larger sample of customers, which we're then going to do customer density upon and do demographic profiling. So there's a fair amount of demographic data we can add to enrich the accessibility of our business data to understand where our customers are, who are our customers, and how can we identify other areas of customers that match a profile where we might not have particular fiber presence or wireless coverage yet, right? And that speaks to demand forecasting. So the first thing is, what we're able to do is, remember I showed the variables for our fiber network, is I'm going to create a thematic map which is going to be based on status, right? So is it planned and is it ready for sale? And we can give it a title. So let's call it Network Status Analysis. And then what I'll do is for the planned, I'll color code that as red, and then as ready for sale, I'll color code that as green, and go ahead and create. It'll now produce a thematic map indicating green areas. If I turn the customers off, it'll be easier to interpret. So we see now the color coding of our network, where we have planned and where we have ready for sale. A very handy feature of the product is the ability to directly from the theme turn off the network, to turn off various results of the analyses specific to the thematic map, right? So it's a very handy way, especially when we get to demographics, to turn on or off certain results of the analysis specific to what we'd like to identify or have a look at as part of our geographic analysis. In this case, I'll turn everything on. All right, so we have our theme, our planned, and ready for sale. Now, with our customers, one of the key benefits of location intelligence online is everything is about the where, right? So where are the customers relevant to our fiber network? And more importantly, which specific customers are located within a specific distance away from the fiber network, and perhaps where a particular value of our customer is equal to a particular number we can specify. So to understand that, remember again, this is sample data, so we're not violating any POPI acts or personal information, anything like that, is if we have a look at the data contained within our customers layer, we see the customer's name, price plan, are they a mobile customer, yes or no, which services they have access to, what was the acquisition date, we have an ID, number of videos, downloads, gender, visit frequency, and total value as well. Again, this is all random information, but of course in real life, we do have access to customers' information. We do know the real value of ARPU. We understand the contracts they have access to. We understand the fiber that they're leasing in order to get network connectivity into their homes. And these are all values that we can play with and understand to do filtering as part of our analysis. So having understood the variables in customers, what I'm going to do now is ask it to do some proximity analysis. And what we'd like to do is understand from a perspective, where do we have our customers relevant to their proximity to our network, right? So for the FTTX network, which of our customers are near X number of meters to our fiber network? So you'll see the ease of use. By double clicking on a layer, very quickly we can get into the ability to produce a filter. And that filter is comprised both of attributes for the particular layer, or we can combine that with different layers that we have within our workspace, right? In this case, the fiber network. And I'm going to indicate a proximity, say, of 30 meters. But perhaps that's not the only important variable, because we have the total value of customer as well. And so what I'm going to do is scroll down under attributes for our customers, and I'm going to add the total value as an additional variable to our query, where that value, for example, is greater than or equal to, and notice how easy it is to do filters and SQL queries using the tool, and also a value of 250 X value per month. Now, what we can do is two things as a result of a filter. Firstly, we could just apply the filter, which would then create a little sub-selection of our filter in this particular layer. Or what we can do is we can apply that and create a new layer with the results. So we have the flexibility of indicating and choosing how we'd like to represent the results. The results will either be filtered within the existing layer, or as I say, we can create a new layer with the results. In this case, I'll just apply it. And voila, we now get a subset of our customer base located within X meters away from our fiber network based on a particular value. And of course, we can add a theme to our customers as well, right? Because perhaps from a priority perspective, what we'd like to understand is where is the concentration of our high value customers. So to do that, I'm going to double click on the customers layer. I'm going to create a map, and that map is going to be based on the value. And very easily, what we can do is increase the number of classes if we wanted to. In this case, it's a range thematic map. We can give it a title, so total value customers. And if we wanted to, we could change the scheme for coloring that we're using. So perhaps I'd like to change it to a darker blue color. Perhaps at the end, top end, I'd like to change it to a red and so on. I'm going to go ahead and create that. So looking at our legend, we can now interpret the total value of each one of our customers relative to the status of our network planned and ready for sale. Now, what this tells us also is that we have lots of customers that are located at the planned, right, status of the network, which means it's very important that from a planning perspective, we dig, we trench, we get the fiber lit, because we can see we have customers located over here, right? And then a different way to indicate or to represent the presence of our customers is to create a grid from that. And so what I can do is, for our customers, create a little heat map. And this little heat map will indicate, if I turn off the total value of customers, the density of where we have customers located relative to our network, so we know where to set the foot team on the ground. Let's get the technicians out there. Let's get that fiber ready. Let's do our marketing activity. And how are we going to market to them? And are we going to go door to door? Are we going to put up billboards? What marketing activity are we going to use in order to attract customers to come to our business? Because, hey, look up, we have fiber in the area, so we know where our customers are. We know where the density is. We understand that this is planned. We've got customers here, and let's get that status changed from planned into ready for sale, so we can attract our customers and start our marketing activity to get those homes lit up, fiber connected to provide internet service. So this is one example of a very small way of where we can understand from a FTTH perspective, in other words, FTTH customers, ways of identifying them relative to location of the network. We haven't yet focused on demographics, and I will get to that in a second. But what I'd like to do now is show you one of two things. The first thing is that if we were happy with this analysis, we have the ability then to save our workspace, right? So we can give it a name. And let's call this our customer analysis relative to fiber network. I can give a description. I can go ahead and save that. Now, if I wanted to open this up, in the top left-hand side is really a home button, right? Analysis page. When I click on that, I can then view, and it'll list all the analysis we've created. I can click on our customer analysis fiber network, go ahead, launch it, recreate the workspace, and go ahead and we can do our analysis, right? So that's a way that which we can create and save and keep our workspaces together. And of course, as I said, we can choose which team members or personnel we'd like to share their analysis with. Now, although this is speaking to FTTH, next question that I have in my mind, of course, is what about FTTB? What about businesses, right? How do we analyze those? So what I've prepared is a workspace, or not so much a workspace, but some layers we can use to analyze locations of businesses, existing versus potential. We're going to look at the size of business, the type of business, located relative to or near a particular fiber network, and analyze those businesses using similar or same techniques. So what I'm going to do now is I'm going to go into this workspaces lookup. I'm going to create a new workspace. And again, using the same technique, I'm going to drag and drop firstly FTTX network 2 into our workspace. And I'll give that a second to render. So this is the fiber ring. It's an example fiber ring. It's not true to life. It's a fiber ring which we use for most of our demonstrations. And then in addition to the fiber ring, what I'm going to do is add POPs or points of presence as part of our analysis as well, again, using the click and drag. Now, when the POPs render, we may decide, well, actually, we don't really like the way in which they look, and so what we can do, as in the previous example, is pop into our layer, go into settings, maybe make them squares, blue squares, decrease the size, I don't know, down to about 5. We can get a nice looking map of where we have POPs relevant to our fiber network. Right. That's the first step. Now, in the next case, when I introduce what we call BizIndicator, which is a data set of around 80,000 businesses scattered throughout South Africa and our country, instead of using the drag and drop technique, what I'm going to do is pick and choose it from a layer that's already been added or imported to a pool of layers, a bouquet of layers that we have access to. So in this case, it's BizIndicator GP, so I've done a filter to show businesses only within the Gauteng province, and I'll click and drag that across, and we start rendering quite quickly. So really what this indicates is locations of businesses, and let's have a look at the metadata. The metadata for businesses or for BizIndicator includes the name of the company, we have some address information, and if I scroll to the right-hand side, we can add columns that we'd like to see as part of our analysis. Two very important columns that stand out in my mind, in addition to the company name and physical address and contact number and so on, ways in which we can firstly classify the business. So we have what we call the SIG code description. So I'll just drag down, by the way, and what we're seeing here are the various contact numbers, email address, the homepage, total number of employees. That's very handy to quantify the size of business. And then scrolling down further, we have what we call the SIG code description, right? So I'll add that. So this really gives us the classification of the company, together with where it's populated, the total size of the company, together with the company name. Now, we could analyze all of these customers, we can do spots and dots, and what I've done, in addition to all of this, is I have a column right at the bottom that indicates if a particular customer is existing or not existing. In other words, we classified each one of these businesses as an existing customer, and if not, then we have a potential customer that we can have a look at. Right. So I'm going to minimize that and close that down. So that just narrates what we're looking at. Of course, we have the POPs that I've mentioned as well, and now we can start analyzing this information. So we could do something very similar. In other words, we can do proximity analysis. We could say, well, please show me all the businesses that are within a certain proximity of our fiber network. And repeat the process like we did before. So to do that, we can hop into BizIndicator. We have our layers. You say, well, we have our network. And show me all of the BizIndicator customers that are within, say, 20 meters of the fiber network. Right, where these customers are existing. So in our case, it's where the value is equal to 1. go ahead and do that filter for me. So what we're seeing now is a subselect from the BizIndicator dataset where there are existing customers, and in this case, the existing customers are relevant and located near our fiber ring. The next thing to understand is, from a profiling perspective, who are these businesses? What do they look like? What is the classification? What is their size? Because if I very briefly just clear that filter and apply it, remember we have many businesses located in and around that we may want to attract to come in and sign up to our network in order for us to provision network and accessibility and internet services. Right? So I'll apply that filter again on our layers relative to the network where there are existing customers. And apply that to come back to our original result. Now, what I've done is, based on this subset, this little filter, is I've gone ahead and analyzed the data. So when we click on the fiber ring, which is our FTTX network 2, I produced a report, and this report is accessible through the internet that analyzes and has produced a result to understand, firstly, who these customers are and what is the quantity of customers that we have already signed up to our services. So when I click on that hyperlink, it'll launch, in this case, my SharePoint, my OneDrive, produce the data for the graph. And what we see is the top 10 customers for our existing fiber ring. If I just scroll up, we have a graph that analyzes those top 10 customers based on business type. Right, so we have courier activities, we have maintenance and repairs of vehicles, wholesale trading, construction, business management, investigation and security services, supplementary health services, activities of state agencies, consulting, manufacturing, freight, transport by road, and so on. And that's just the top 10. But in total, we have around 250 customers that have signed up for services on our particular ring. So the beauty about this is we have the ability then, if we wanted to and take it further, we could make a note and a list of this classification of them, using the filter capability, go ahead and produce a filter, which would then ask it to please show us where we have locations of these particular businesses by type, perhaps located relative to or within accessibility of our fiber ring, so we can go and approach them. We can do knock and drop, do marketing, go and canvas our services in order to get them to sign up. So this is one way in which we can analyze from a business perspective existing and identify potential customers. I'm going to close that down and come back to our analysis. Now, a different way we can do that is if I just scroll around in the map over here, you'll see we have a POP and we have Longmeadow Business Estate. So we have a business complex located within accessibility to a particular POP. What I'm going to do on BizIndicator is I'm going to clear these filters, apply that, so that we can see, in fact, we do have business customers located over here in an area within which we don't yet have coverage or service availability. So to understand that, what I'm going to do is, and I prepared this, it's a layer which we call Office Park Atlas. It's really boundaries of business estates, and I'll drag that across. And that's available for the business estates in South Africa. It'll take a second to render so that we can get that polygon that comes back. Right. And then what we can do is start understanding from a volume perspective. I'll just move that down so we can see the BizIndicator above it. From a volume perspective, what is the total number of employees that we have? How big are these businesses? And does it make sense for us to expand using existing POP A or possibly existing POP B over here? Okay, there may be some trenching involved. Does it make sense for us to expand to offer services in this particular office park, in this case Longmeadow? And if so, what do those businesses look like? Right. So the first thing we can do is understand, well, what is the number of employees? What's the total? And again, we've prepared that. And perhaps what we'd like to do is say, well, actually, I want to see in Longmeadow Estate just all the businesses are located within there as a little filter, right? So these filters become very handy and very quick. And in this case, what we can do is create a new layer with those results. So we'll see it rendering. I'll turn off BizIndicator. So now we have a little subset of all of the businesses that are located within the Longmeadow Business Estate Office Park. And perhaps what we'd like to do is under its settings, we can give it a different name, and let's say, well, these are potential customers. In Longmeadow, right? We can color code them and so on and so on and so on. So we get this little subselect. I'm going to close this. I'm going to apply it. The next thing we can do is from our potential business customers, let's understand where we have a high concentration of employees. So remember, I spoke to all the variables that we have, the address information, company name, contact information, and so on. And as part of that, we have company size as well, total number of employees, right? These are all the variables that we have. So to do a quick search, I can say, well, EM, we have the employee number, so we can very quickly get to the attribute that we're looking for. I'm going to drag that across so that for the Longmeadow Business Estate, we can understand where do we have high and low concentration of employees. I'll go ahead and create that. And then we can filter and turn off any which might not be relevant. So we can turn off the 0 to 10, right? So we'll see those disappearing from our map. So there we see, just in terms of the high number of employees, from a priority perspective, where these businesses are located. Now, I've taken that a step further, because although from a priority perspective, and we can get to planning, in terms of the fiber network in a second, very similar to the previous analysis, what I did is I exported that data into Excel. So this is the Longmeadow Business Estate. And again, we can produce a little analysis, stored in this case via SharePoint, which indicates to us the number of employees. In other words, from a volume perspective, is this viable for us to go and offer our services to plan and get some sort of fiber presence on the ground? And what we see is the total number of employees coming in from that sum analysis we did a few seconds ago for each one of the classifications that we have. And this is really just the top 10, and of course there could be more. In some instances, we do have employees, and where it's not populated, we don't have it, and this is just the nature of the data set. But looking at this, if we just insert a new record there, and do a quick sum. Right, got around 1,000 people. Right, 1,000 people isn't bad volume, right? In terms of an area into which we'd like to expand. And so we see the majority of employees are in information technology. The bulk of it then is courier services. We have warehousing and distribution, which would make sense, right? Because it's semi-industrial, wheel services and repairs, beg your pardon. Automation, services and equipment, engineering, diagnostics, motor vehicle hire, and so on. So we can get a classification of sum of employee that exists within the Longmeadow Business Estate. So let's assume that we agree this is viable. The next step then is we can produce a little plan, a little fiber plan. So I'm going to go back and close that. And I'm going to minimize that little lookup. And that little plan, what we can do is, once it's created, we can drag and drop it down. So we have our little FTTX, pull that across, leave that to render, which means that we can do a breakout from this Longmeadow POP, right? And from that breakout, we can start deciding, just in terms of priority, where the high volume customers are, where we'd like to, from a priority perspective, as I say, do our planning and our prospecting analysis. If I turn those other customers back on between 0 and 10, we can see where those customers are located, and perhaps we'd like to first start targeting or canvassing over here. right? So that's for the IT. Start canvassing for the other customers as well, again, just based on the total size of the company. Where do we do this from? Well, this is drawn either from MapInfo Professional, or we can use a product like Connect Master to produce a plan, upload it, and make it available to the sales personnel in order for them to go and do the particular analysis with. So that really speaks to ways in which we can identify potential customers, right? Potential customers for businesses, existing customers for businesses, do a profile based on them. In this case, identify a particular office park to which we'd like to expand the network into, and so on. Again, if we wanted to, we could save our workspace. We could say, right, well, this is our BizIndicator for Longmeadow. Save that as a result. It's also possible to, based on the company size, determine the sort of products and turnover we can expect, right? We might expect a larger company to have a bigger internet line, maybe smaller companies will have a smaller pipe. And so it's possible then to, from an ARPU perspective, average revenue per customer, if this information is known, because ordinarily we classify existing customers, so we know our existing customers, we know our existing customers based on value, we can incorporate those values into potential value and then analyze a potential value or expected potential value if we were to expand our network into a particular business estate. So that's one way we can analyze businesses. But what about households? What about individual dwellings? I mean, we had our first analysis where we had a smaller customer sample relative to a particular fiber network, but what about a much larger sample? To analyze that, what I'm going to do is I'm going to clear my workspace. So we have a fresh start. And really, again, probably a series of layers we have available to us, one of which is called APT Customers. So I'm going to drag that down and we're going to get a nice surprise. I've got this habit of always dragging down, and it's something which Miguel showed me yesterday. If I just remove that layer, a different way to get the layer in is to just simply drag it across into the right-hand side of the map. And notice how quickly it actually renders. The performance is super. Stepping into, if I just zoom out a bit, stepping into this, we have around 200,000, and this is just a selection of what we call APT. So what are we looking at? The APT indicates location of a rooftop, and that rooftop is classified according to either a single dwelling unit, and we also have multiple dwelling units as well, right? So it's location of a building. And that's very handy from a planning perspective, because if we're targeting multiple dwelling units, we can do a filter based on that. Multiple dwelling units will indicate the total number of units that exist within a particular complex. It's classified by name as well. And in addition to the APT customers, is rooftops. We'll minimize that. We also have cadastre data. So what is cadastre data? Cadastre data is really the property boundary, right? So I'll give that a second to render. So what we're seeing now is the APT database, location of rooftops, and we're seeing the boundaries, the property boundaries, coming in from the CAD. Now, by the way, each one of these APT customers, again, as a sample data, and let me just step into the data itself, does have a classification, and that classification is a customer existing or not? And again, this is sample, it's random information. So the first thing we can do is possibly color code existing versus potential customers, but that wouldn't make any sense unless we have some sort of fiber network. So to do that, what I'm going to do is bring down a network layer that I prepared. It is sample data, it's called Fiber Network GP. So I'll bring that across. And this would indicate an example of an existing fiber ring or a fiber network, in this case in a residential area. What I'm going to do is override the style for that. Oh no, it's got to be done separately. I'll leave it as it is. What I'm going to do on FiberGP is first you take a little selection of this area. Because if I just do a quick analysis of the customers that are existing versus potential, so it's very similar to what we saw in the BizIndicator dataset. I'll say 0 marks potential, so let's have those as green. Red marks existing, so we'll mark those as red. And say this is our existing versus potential FTTH. Right. So I'm going to turn off the APT customers. And let me push that cadaster down so we can see more clearly the classification of customers. So the green indicates potential, and the red indicates an existing customer. Right? Remember, we can turn them off. So we'll say, well, I don't want to see my existing, I just want to see location of the potential customers. And we can do a little subset based on that. Of course, this is not doing it for the whole of Gauteng, not just for the area that we're working within. Okay, it become a little busy. I'm going to zoom back into this area. Now, let's say what we wanted to do is understand from a density perspective in this little area, the total number of customers. What is the potential we have for our fiber network? And there's a very handy way we can do that. We have the ability using Shift to do a select of objects to the map. So I'm going to do a little selection of these objects, right? And we'll see we have 113 elements that have been selected. So 113 fiber segments that have been selected as part of my little selection process now. Beauty about this is from this selection, we can filter or we can create a layer based on that selection. And in this case, I'm going to create a layer. And I'll give it a few seconds to render, and we see Fiber Network GP. Right, so now when I turn off the entire network, all we're seeing is a little subselect coming in from our network, right, relative to potential customers. The next thing we can do is, if I step into our fiber network layer, is under proximity, we can create a buffer. And let's say we want to create a buffer of, for example, 30 meters, 20 meters, or whatever the case may be. I'll create a buffering of 20 meters or even 40 meters if we wanted to. Go ahead and create that as a layer. And there we see the buffers being returned. Okay, they could be a little bit larger. We might get a little bit of fallout, but not too important, so we can increase and decrease the size of our buffer. Now, what value does this add? Well, what we can do is, if we step into the buffer, we can do some calculations based on layers. We can say, well, you know, we have our customers, we have our existing customers, this existing versus potential. We have our CAD, we have our APT customers, so we have our APT customers. And what we can then do is count the APT customers that exist within our 20-meter buffer, right? And remember, it's based on a filter, and that filter is based on the potential customers. So let's count off potential customers within our particular area, right? I'll apply that. And what that does is that it creates an attribute called counted potential customers. Now from here, what I can do is create a thematic map from that. Again, we can change the color scheme. So for example, dark blue, perhaps into a red color, and go ahead and create that in the buffer. And immediately it paints a picture for us, because right away we can see where we have a much higher concentration of potential customers relative to a lower concentration of potential customers. We know right away where to go and focus canvassing, marketing, advertising, presence in the network. Is it door-to-door advertising? Are we handing out pamphlets, Are we going to go and put up signs on the billboards? Is it going to be media? Right away, we can see location of potential right away. And if we had, which I don't have in this case, but if we had the expected revenue per customer based on the average, for example, size of the household, or based on some sort of additional variable, and we're going to launch into the demographic side of the analytics in a second. If we had that information, we could then quantify it. And when we quantify it, not only do we see where the customers are located potentially, but we can add a value to that in terms of turnover. And when we add a value in terms of turnover, we know from a priority perspective where to go and focus sales and marketing activity and footfall on the ground. So, very, very handy ways in which we can identify very quickly, in this case, a buffer from our street selection, from our network, understand the count of customers very quickly based on a filter that we have on our map to identify location of potential. Right, but what we haven't understood yet is, from a profiling perspective, what do these customers look like? In other words, from a market segmentation perspective, what sort of income profile are we looking at? What sort of market segmentation profile are we looking at? Does the size of household make a difference? Is there a particular income bracket we're looking at? So the idea is that from here, not only can we identify at this particular level, at this sort of micro level, location of potential, where we have network presence, but it's possible to expand that analysis to understand much more in a much larger geography, more information about our customer. So to do that, I'm going to clear this workspace. Again, we could say with clear that. So we have a fresh start. I'm going to drop the APT customers across like we did before. And in this case, like we did, I'm going to do a filter because what we're interested in is understanding more about our existing customers. So that's where our existing customer is equal to 1. Let's create a layer with that. And give that a few seconds to load. So I'm going to turn that off. And this is going to be called existing customers. Okay, so we can see where the existing customers are located. All right. Now, these spots and dots can become a bit messy, especially as we zoom out. The more we zoom out, we're going to get more clutter and more noise, more white noise and so on. So a very handy way of understanding customer density, as we did before in a previous example, is ask Ally Online, Leo as we call it for fun, internally to create a heat map for us. And this will indicate to us the density of our existing customers, right? Not too much the potential side of things. So this is where we have presence. These are guys who have signed up. They have access to our services. Remember, we have a fiber network for GP. If I just bring that down or drag it across. Right, so we have fiber presence. I won't leave it there, I'll turn it off because it is creating a bit of clutter. So the question is, from a demographic perspective, who are they? What is their income, and what is their market segmentation, and how does that look? And how can we analyze that? So I'm going to zoom out a bit more. It's a very nice looking map. Notice how quickly it renders as we zoom in and out. The performance is fantastic in a situation like this. And what I'm going to do from a demographic perspective is drag and drop across a dataset, which is called census squared. In this case, it's households. Excuse me, and that's available at what we call a subplace level, right? Which is similar to a suburb that we have available in South Africa. So I'm going to drag that across, and we start seeing that rendering, and then we can do some very clever things with this demographic information. And the first thing that we'd like to do is, from an existing customer perspective, what is the density of customer in each one of these? Right, so we need to do a little bit of mathematics and some calculations. So I'm going to ask it to produce a layer for us. I'm going to do a filter. where the existing is equal to a value of 1. And I want to create a layer with those results coming in from the APT. And give that a second to load. Okay, so if I turn off the theme, these are our existing customers as a layer, APT customers. What I'm going to do is step into its settings, and I'll call this existing customers. And I'll close that. All right. Now, why that's important is because what we'd like to do is do a join. So we'll do a calculation. And that calculation will be where we have our existing customers. Just to make sure that's right, existing customers 2. And what we'd like to do is count the existing customers. So let's, or maybe do a sum. No, count is good enough. So we'll do count. Of existing cust. So we're doing this on the fly, right? I'll apply that. And what that'll do is create an attribute for us, which is count of existing customers. And then, of course, what we could do is we could say, well, let's create a thematic of that and see where they all are, and so on and so on and so on. But maybe what we'd like to do is take it a step further and say, well, what I want to do is I want to take the count of existing customers to get some sort of density profile. And we can do a search for here. You'll notice it does remember some of my previous searches. And what we're looking for is total number of households. So we'll do a count of existing customers divided by the total number of households, and then what we'll do is times it by 100. And let's call this customer density. Now it'll become a variable, and we'll apply that. I'll remove the filter. So we have our customer density, beg your pardon now, I said customer density analysis as an attribute, as a variable that we can use for analysis. Now, this is where it becomes very exciting. Because under map, we can produce a theme of our customer density, right? I like changing the colors, blue into a red. Let's make that more of a yellowy color so we can see the spread. I'm going to go ahead and create that. I will turn off the APT customers and the existing customers too. So straight away, we see this very high concentration, right? I think there could be something up with the calculation, but I won't worry about that now. We have a high and lower concentration of our customers relative to the census squared information, right, based on density. So I'm going to double check the calculation on that filter. No, we can't, because we created layer based on that. Not a problem, we're not going to worry about that. Now, let's assume then that this clearly identifies where we have the high and the low concentrations. The blue we're not really worried too much about. What we can do is step into what we call dashboards. And the dashboards become really exciting because in addition to not only the thematic maps, we have the ability to analyze in terms of graphs, a bar graph, and a pie chart, or using just values of information. We can configure what we'd like to see when we click on these particular areas, right? So what do I mean by that? We can do profiling. So when I configure the dashboard, I can remove all of these variables and I can say, well, of importance to me maybe is income variables. So we can drag those across and take a handful. Let's call this income analysis. Right. And then perhaps in addition to that, what we'd like to have is, as part of this data set, we have market profile, market segmentation variables. And we'd like to do some market segmentation analysis as well. And let's call that market segmentation. and save that. So now, the power behind this, oh, by the way, what I want to do is analyze this as a chart. So I'll say that it'll be a bar graph. And then for the market segmentation, I'd like that to be a pie chart. And of course, we can add one or multiple, in this case, just examples of ways in which we can configure our dashboard to come back to us. So I'll save that. And again, of course, we can save the workspace as well. But now look at the magic of what it's telling us, right? We have total 2,500 subplaces within Gauteng. The bulk of the income is located above 750,000. This is annual income analysis for the households. The market segmentation is really from a deprived, middle class, and poor. And that's really for the entire Gauteng. But what we can do is we can say, well, what's happening in this area over here? We've got a high concentration of customer. What's going on? Hang on, I should have saved my dashboard. Customer density analysis. Wait, let me just turn that off or push that up. Okay, so in this little subplace over here, interestingly enough, the majority of market segmentation is poor. We have some deprived, with low MC, rich, middle class, and so on, and we see these income variables coming through as well. But if I use Shift, we can go away and select one more and more and more subplaces relative to where we have concentration of our customer in order to understand from a profiling perspective who these customers are, right? Who are they? Middle class and poor. What does it mean? We understand where they are. We can extend that into understanding, well, from a product perspective, what sort of products are we offering? Are we talking mobile money? Are we talking at a retail perspective, a different value in terms of handset? Are we talking prepaid? Are we talking postpaid? So it speaks to, from a demographic analysis perspective, the product mix based on the target audience. And that product mix will come down into store level. And then from store level, that'll be extended into billboard, media advertising, and so on. And of course, we can go into additional variables because we have things like language. We have the age group profile and so on. So maybe we're targeting a particular age group towards a particular product because we understand that a particular age group A is more likely to buy a particular product of a particular value and go away, and we can identify those. So it's a very nice way in which we can represent and very quickly get to understand who, from an existing or potential customer perspective, they are from demographics and in this case, income variables as well. So what I'm going to do now is step away from this because I'm just conscious of the time. I'd like to open up to some questions as well. And what I'd like to do is showcase some additional data we have. These are analyses that I've already prepared that have been saved, which will speak to demographic information in Kenya. And then in Mozambique, some POI analysis relative to propensity or potential to have a little fiber network as well. So I'm going to step out of this. I'm going to step into our analysis page. I'm going to leave this. Of course, we could save it if we wanted to. I'm going to leave that. And I'm going to start with Mozambique. Okay. So what we're seeing in Mozambique, this is for Maputo. We're seeing, in this case, population density analysis at a hexagon level. This comes in from one of our data suppliers. And really, at a glance, we can see we have a high and low concentration of population. Right. In the background, we have our here API. It's giving us the background maps. And what we're able to do then is overlay additional vector. Okay, and that vector would come in from what we call our QSP dataset, which is Quality Spatial Platform. And the QSP dataset offers vector, which would be things like streets, suburbs, cities, railway boundaries, railway lines, and so on, administrative boundaries, so that in terms of a population analysis perspective, where are they? If I were to turn on, for example, suburbs, and give it a second to render, we can have a suburb name so we can see within which particular suburb, where do we have a high and low concentration of our population, right, based on this population estimates. So very quickly, we can see just in terms of where they are, where do we have population. Of course, if we had additional information, for example, coming in from a telco, we might have, for example, locations of towers. We might have the boundaries for the towers. We might have a fiber network. And where's a fiber network relative to a particular location of population? What is the income, which I'm going to talk about if we have time, the Kenya side of things. So it really opens up ways in which we can analyze data, not only for SA, but for neighboring states as well. So what? Because in addition to just the population, we have an FMCG database, and I'm going to go ahead and turn that on right for Maputo. And really what this gives us is a classification of fast-moving consumer goods database scattered in and around, in this case, just a lower part of Maputo. Of course, we could analyze it, so we can analyze it by type. I'll give you a sneak preview. If we just pop into not so much the railway side of things, but the retail data set. In here, we do have classifications. So we'll see the trading name, the trading as, the buildings, do we have road access, what is the market segmentation, and there's a few additional juicy columns as well. And really, what that allows us to do is to produce a filter, right? So that filter could be based on particular aspects, businesses, schools, places of entertainment that we'd like to understand from a cluster perspective, right? So I'll turn off the population analysis. So we're just seeing the FMCG. And we do have a street select, which I'm going to turn on in a moment. And then I'm going to turn on the result of that filter. And I'll turn off the FMCG. Oh, by the way, that's a little thematic map that's coming up. If I just pop into the legend over here, it's an analysis of the classification of each one of these spots and dots of the FMCG. So we can have close proximity of bus stops, we can turn them off. Entertainment, maybe we want to leave on. Clinics we can leave on. Mainly businesses, marketplaces we mightn't be worried about. Residential areas, yes. Schools maybe not. Shopping centers maybe yes. Taxi ranks and train stations off. So there's different ways that we can use to quickly get to identify and understand location of businesses, places of importance that we'd like to market our product to in order to plan network rollout. So very quickly, we have streets, right? So from streets, it's easy enough to produce a plan. It's then possible to, like in the previous example, buffer those streets. So we have a little buffer, right? In this case, it's already been created. And then what we can do is count, based on the buffer, right, places of importance. So what this indicates to us again is level of priority. Where do we have a high concentration of a filter? Where that filter is based on, in this case, entertainment, businesses, schools, and hospitals, counted into that particular buffer. From a planning perspective, our little network. So I'll just push the network up. Right, above the little buffer. So we can identify places of priority in order to plan. So we might have a phase 1 where we have high density, we might have a phase 2 where we have a lower density, and a phase 3 where we have even less density. In this case, speaking to just to fast-moving consumer retail goods FMCG database. We do have a points of interest database as well, which I want to showcase now in the Kenya example, but this is a very nice way in which we can understand population, use points of interest, creatively, of course, in order to identify potential and marketing activity and so on, as I say in this case for Maputo. So I'm going to step out of this analysis, step into Kenya. So I'll come back to our analyses, and we have a Kenya census telco demo. And like in the case of Maputo, everything has already been done for us. So the first thing is, we have some demographic information for Kenya. If I step into that, you can look at some of the variables that we have. So scrolling from the right-hand side or left to right, we've got some gender profiles. We have some age group profiles. And if we click on add columns, so it's gender, and the age group analysis. We do have other data sets, and if we have time, and I'm concerned about the time, we might showcase them, we might not, and if not, I'll just bring up a little spreadsheet that indicates what we have, and the variables are available for the countries throughout Africa. Okay, so this is speaking to population analysis. So the first thing we can do, of course, is understand, well, where do we have our high and low concentration of population, and immediately we can get these results coming back. So I can click on an area, and in this case, all pre-prepared. We have a gender analysis, and we have an age group profile for a particular area that's coming back. And as you saw in the previous examples, again, based on high concentration of customer, or in this case, high concentration of population, what is the age group profile, and is there any difference between male and female? I wouldn't think that necessarily we might have a difference in terms of product offering for males and females. Certainly from an age group profile, that could add value, and I'm also selling population as well, right? So we have 305,000 people living in the areas that I've selected over here. Now, I spoke about the POI, and that's points of interest. So I'm going to turn off the population and then turn on the POI. I don't know if I drag that down. I might have done a filter based on that. Let's just turn this on. So what we're seeing is concentration of POI, the points of interest data set, right? The POI will indicate a category, a subcategory, business names, some sort of classification of the POI. What is it? And what are we looking at? And then it's possible to do a filter based on that POI. So let's say of importance to us was locations of businesses and schools. This is a predefined filter that's already been run. This will indicate to us locations of businesses and schools, because perhaps this indicates to us location of our target market. Once we have that filter, by the way, and a very nice feature is that if I just step into the businesses and schools, this subselect will give us a good indication of how that data looks. So we see the name of the school in this case, the location name and its province. This is just for Nairobi. The SRC category, which is school, and there's 1,070 POI that meets the criteria of schools and businesses and so on. And of course, it could be anything, right? This is just an example. A very handy feature is the ability to export that data. So from any query, any result, anything we're looking at in the product, we can fire that off, produce a little Excel spreadsheet, we can open it up, and that will quickly give us the result of schools. And if I scroll down, we've got some business parks, agriculture business that match the filter criteria. And that was just a little example of the analysis that we can do. Now again, we can do some sort of proximity analysis if we wanted to. If I come back to our little map over here, we have streets. So the streets could represent a fiber network. But very interesting is what we have. It's called a company. It's called the GTI, Geoterra Image. They're a product which is called ward summaries. And the ward summaries data, the variables are described as things like population and the dominance age group for a particular ward. In addition to additional variables as well. So we have some land use classifications, which are residential, are they informal, backyard dwellings and so on. But there's also indication of the quality of fixed line in a particular area, right? And that becomes very handy. So we can understand, based on the results of research, this is from GTI, one of our partners, based on their research, their estimates, what sort of internet quality do we have in these particular areas, and more importantly, where, in which suburbs do we have high availability of internet quality? By the way, if we look at the thematic, anything that's between 2 and 3 is really low, so it's poor quality. So we'll see poor quality to coverage over here. And anything red, anything 6 and above, is a much higher value of internet quality. You can see over here as well. So this indicates the value of, well, hang on a second. If we have these particular areas, who are they? What do they look like? So we could go away, we can produce dashboards. Let me turn on the GTI ward summaries information. And I'll turn off those summaries for a second. Click on this. Let's understand what are we looking at here. So what we see is a large concentration of LRS iron, and that means that this is informal settlements, right? There's a high concentration of formal settlements as well, with some backyard dwellings. So very quickly, from a land use perspective, we can understand what's happening on the ground without physically actually being there. By the way, this PI category analysis is health. So we see concentrations of what would be schools, educational sites, health sites, POW. POW is places of worship and sports sites as well. If I click on a different area, we'll see that category analysis coming through. So very quickly, we can sort of hang on a second. And in these areas where we have high concentration of very good network quality, by and large, this is formal residential area with lower concentration of informal. And from POI category, in other words, land use, the higher concentration of schools, got educational sites, got some health sites, places of worship and sports sites as well. And again, we can do multiple analyses. It's also possible to do comparisons. If I lock that, click on one area, click on a different one, we can do comparisons based on these different areas we're clicking on, using our dashboards, using the data available to us, using alphametric maps in order to get a really good feel, not only from a usability and ease of use perspective, but understand demographically, from a classification perspective, the data availability that we can use to analyze very easily the target markets and applications for location intelligence online in the telco space. I'm going to pause it there because I've been waffling along for the last hour or so. I'll stop my screen share. I'd like to open up the floor to any questions or any feedback from our delegates, any comments and any questions you guys might have. Please feel free to ask away.
Thank you, Mark. Thanks for a very comprehensive overview. Any questions?
I think there are questions on the chat.
Oh yeah. Okay. What data sets are provided with the system? Well, we have over 30 data sets available to us. So it really comes back to what you require. Map Ideas doesn't come bundled with specific data. So it's really, we license data based on the request because there's just so much data available. Is this system built on top of another GIS map info on which it was made more user-friendly? Well, it started from scratch, really. Miguel?
Yes, that's I'm smiling because my dear colleague Eduardo and CTO typically says, "Oh, you guys have the dreams and we have the nightmares to do it." It's completely designed from scratch. It uses the Postgres database as the engine, and everything. It was pretty much inspired in MapInfo because I'm a very heavy user of MapInfo for a long time. But the idea is to appeal to an audience that doesn't know how to use any ArcGIS, MapInfo, QGIS, because it will be overwhelmed with functions and buttons. So it's from scratch.
Thanks, Miguel. Can this system be integrated with CAD systems by means of an API?
I think we should qualify. Are we talking AutoCAD or are we talking Cadastre?
Yes, so that was my questions. AutoCAD specifically.
Thanks, Ignatius. I think that's one for you, Miguel.
Yeah, I hate to say no on these type of questions, but unfortunately is no. So directly there is no way to integrate. What we do have is the ability to connect to different data sources, not only databases, but also to Google BigQuery, Microsoft OneDrive, and Google Drive. So in some situations, people place their data on these systems and then they fetch that to MapIdea. But again, the answer directly is no.
And the last question was, can this system communicate with DWG, shape or tab file formats?
I can jump on this one also. Well, it can ingest practically any type of geographic formats. I'm not too sure about the DWG. We are always adding new sources, but it can ingest shape files. What Mark was doing with tab files can be perfectly done with shape files, with GeoJSON, with CSV, with coordinates, even with well-known text, or even in Excel or Google Earth files. Again, some of the non-technical use cases, they rely on Google Earth to do some drawings, and then you can perfectly drag and drop them to Map Idea.
Okay.
Thank you, Miguel. I see Kasia has got a hand raised.
Yep. Kasia? Kasia, you have a question?
Kasia, can you hear us? If so, we
Kasia is
can't
writing
hear audio on your side. No, not at all. We can't. But feel free to type away, Kasia.
How accurate is the data? Well, no data source is 100% for sure. That's why we offer products. All our data is offered with maintenance, because you're constantly updating it, either annually or 6 monthly or whatever. So I think there's no data that's 100%. We would say that most of the data we sell, in fact, all the data we sell, is at least 80 to 90% accurate, but we're always updating it.
Alan, I've just shared an Excel spreadsheet indicating country by data availability, just to give an overview in terms of what we have. And if there are questions around specific countries or specific regions, please feel free to ask. And we can share both samples of the data, as well as indicate particular variables, subsets of data we have access to for the countries located around Africa.
We have some data. The question was, how many countries do you have data for? We have most of the data we have is for South Africa, but we have data for all African countries. Certainly the main African countries. I think the countries where Liquid is active, we have data for. Does that answer your question, Kasia?
Kasia just giving us a thumbs up, so that's a positive sign.
Okay. Any more questions? Okay, thanks. Thank you.
Thank you, Kasia.
Allow me to add something regarding the data, not exactly about the quantity of countries and the accuracy, but and we find this on several projects that we participate. The data value doesn't add, it multiplies when combine external data sources with internal data sources. And on the telco space, it's one of the industries that has more data available. So putting all the customer behavior on the map, plus the location of the cell sites, plus the network, now even the top boxes of the TV and the usage, combining with census data and some of the data sources that Mark showed here, it really creates a new level of information to make accurate decisions. And it's a pleasure to work with that data, because it's something that we never saw before. It's not something that you can simply download from somewhere.
Thanks, Miguel. Thank you.
Yeah, I'd like to comment additional to Miguel's comment, and that is, it's also very good at doing temporal analysis. So the ability then to ingest, for example, cell sites and cell areas, to understand on-net calls, off-net calls, in other words, calls that are on a network or calls that are off our network, together with drop calls, using temporal is a very strong feature of the tool, using the configuration of the dashboard in order to identify where we might have problem areas, problems with the towers, high calls being dropped or high call volumes are being experienced, and so on. So in addition to the business data, in addition to very static thematic mapping, which I've created, temporal analysis is supported by using the products as well.
Thanks, Mark. Any more questions? Okay, guys. Oh, NAD information seems to be a national issue.
I think entirely is best to comment on that, because remember, we have
Yeah.
two data sets,
Yeah.
Ignatius. The one is the NAD. NAD can become very costly depending on the data source, which is true NAD, right? So it's a proper national address dictionary. We have what we call a poor man's NAD. And the poor man's NAD is really a rooftop, which is essentially entirely, correct me if I'm wrong, inferred based on the street address range dataset to produce the house
100%.
number. And that then lines up in many cases with the location of the cadastre boundaries. So it's really accurate. We like to think of it as a poor man's NAD. Coverage can be a problem. It's typically limited to urban areas, but it's really how we get around it.
Yeah, and we find that upon each release of that address point data set, they are constantly working towards your more rural regions, or at least just the boundaries of your urban areas where we constantly see growth.
Yeah.
So that is another plus. The data set is updated biannually, so you would receive an update twice a year.
Ignatius, the source of the data is MapIT, previously TomTom, just as an FYI. In comparison to someone like Averages, where they have their own ad, but the cost comparisons, you can't compare the two.
Thanks, guys. If there's no more questions, yep.
You're welcome.
Okay, just as a final, if any of your colleagues couldn't attend today, we will be putting a link to the recording of the webinar on our site, on our website, and we'll certainly be sending to people that couldn't make the event today who did register. Yep. If there's no more questions, I'd like to thank Miguel and Mark, and we'll talk again soon.
Thank you, Alan. Thank you, Miguel. Thank you
Thanks,
to
guys.
you attended. Thank you for your attention.
Both.
Thanks. Thank
Speak
you.
soon. Bye bye. Thanks.
Bye.
Thanks a lot.
Thank you. You're welcome. Bye bye now.